So we're going to be using the first derivative to find out where this function is increasing, decreasing, also to find minimums and maximums, and second derivative for when it's concave up and concave down. So I'm just going to use the first derivative, information over here on the left hand side. So the derivative of this is going to be, the derivative of sine is cosine, and the derivative of cosine is negative sine, so that's going to cancel this negative. And there's no place where sine or cosine are undefined, so we don't have to worry about the derivative undefined. Now just find out when does it equal 0. Or in other words, when do sine and cosine cancel each other out? So what I can do is move one of these to the other side. I'll subtract sine from both sides. And then if you divide by cosine, we would get sine over cosine on this side. So divide both sides by cosine. And this right here is tangent. We can take the negative and move it to the other side, so we've got tangent is equal to a -1. Well, the graph of tangent has asymptotes at pi over 2 and negative pi over 2, and then it looks about like this for one branch of it. So this is now asking, well, where does tangent equal a -1? So down here's -1, and then the calculator, if we use tangent inverse, is going to find us that one right there. So make sure that the calculator's in radians. Right here in the directions, that says you should be using radians. Very good. And then tangent inverse of a -1 is a negative, looks like pi over 4. We can check by saying divide that by pi. Sure enough, that's -1/4 of pi. So we get that x is equal to -pi over 4. But the problem is the directions say that I should have positive answers. So that means I need to follow this graph over farther. There's going to be, let's see, that's half of pi, so pi would be right here, and then 3 pi over 2. So there's another branch of tangent that looks like this. And if you followed the graph over at a height of -1, then right here, there's going to be another. So that's going to be between pi and pi over 2, where the asymptote is. Excuse me. Between a half and a whole, it's probably 3/4. But let's see. So this says from where it's crossing the x-axis, move over to the left by pi over 4. So we can do the same thing here. Where it's crossing the x-axis, move over to the left by pi over 4. So that would be a pi minus a pi over 4, sure enough, is 3 pi over 4. So we get 3 pi over 4. And then what I should probably do is take a look at the graph, sine minus cosine, so a graph of the original function on the interval from 0 to 2 pi. And there's two places where the derivative is going to equal 0. Up here for a maximum, and down here for a minimum. And we can trace and see if that 3 pi divided by 4 is correct. That one's correct. Now we need another solution. Well, if we went out a little bit farther, then down here there would be 2 pi. And to do the same idea, from 2 pi, move to the left by pi over 4. So that's going to be 2 pi, move to the left by pi over 4. So that's going to be 8 pi over 4 minus 1 is 7 pi over 4. And just to double check, is that the 7 pi over 4? So we've got 7 pi over 4, sure enough, is the minimum. Okay, so we've got a minimum at the 7 pi over 4 and the negative 1.414, which probably has something to do with the square root of 2. Then we had a maximum at 3 pi divided by 4. And then we need to know, where is it increasing and where is it decreasing? Well, increasing would be in this area. So if I back up a little bit and say start at negative 1, you can see that as it goes through where x equals 0, it was increasing. So when I go to say the increasing, I will include the 0. It was increasing there. And when it got to this value, which is that 2.356, it's no longer increasing. So use a round parenthesis there. And then at the end, this little part right here, it's also increasing. So you've got union starting at 5.498 to 2 pi. Now, technically at 2 pi it is increasing, but according to the directions it says to use a round parenthesis and don't actually include the 2 pi, and so I do the same there. And then for decreasing is just this middle part from the 3 pi over 4 to the 7 pi over 4. So this would be the 3 pi over 4, and then the 7 pi over 4, but don't actually include those points, because at the top it's neither increasing or decreasing. Okay, so we have all the first derivative stuff finished, and now for the second derivative. So take the derivative of this, and we'd have negative sine for the derivative of cosine, and then cosine of x for the derivative of sine. And do the same thing as last time, set it equal to 0, and move one of the trig functions over. And the only difference between this and last time is that it's going to be that tangent of x equals 1. So again, with the graph of tangent, there's an asymptote, another asymptote at the pi over 2's. With the last one it said, where does that equal negative 1? This one, where does it equal positive 1? Well, the last one was at negative pi over 4. So by symmetry, this one's going to be at pi over 4. And then, like last time, we need to continue this out. So here's going to be pi, and here's an asymptote of 3 pi over 2. And here's 2 pi. So we'd have another value over here to the right of pi. And then the next one, the directions say you don't need to go beyond 2 pi, so the next one would actually be over here, which is beyond 2 pi. So we've got these two, pi over 4, and then from pi, go over to the right by pi over 4. So that would be a whole plus a quarter. 1 1/4 is 5 quarters. So 5 pi over 4 from pi plus a quarter of a pi. And then these should be the critical values for the second derivative. In other words, where does it change from going concave up to concave down? So for example, all of this is concave down. Somewhere right about here or so, it changes and then it's concave up. And somewhere over here or so, it changes and that side is concave up. So let's see, trace and try pi divided by 4. Okay, so this side is concave up, and also try 5 pi divided by 4. Alright, so in the middle it's concave down, and on the two sides it's concave up. So we've got, where's it, concave up? So that's over here, so again start at 0. And then it goes to, that one was pi over 4. But at pi over 4, that's an inflection point. It's not concave up or concave down, that's where it changes from the two. And then we've got from 5 pi over 4, so this side over here, to 2 pi. And again, round parenthesis on that, only because that's what the directions say to do. And then concave down is going to be in the middle. So from the pi over 4 to the 5 pi over 4, this middle part is concave down. And there's everything asked for.